Hi everyone. 2.2 is kind of a quick section. I want to introduce a few more function shortcuts before we jump into more of our general shortcuts, product and quotient rules. So I want to snag sine and cosine derivatives. This first page is kind of your preview page, get you all ready for going through the limit definition of the derivative. And then we'll crunch that and do some examples, and you'll have just a short homework on this. So go ahead and pause and remind yourself about a few of these things. And then go ahead and come back through and double check if you want to. Okay, so, let's see if I can think about this. So the first one, we're going to use this on the next page is the big reason it's here. But remember, you can find value of limits numerically. Here, if we plug in 0, cosine of 0 is 1. So we have 1 minus 1, which is 0, divided by 0. So it's indeterminate. And here as well, sine of 0 is 0, so this is 0 over 0. But these are actually really nice, handy limits, more than just for what we do on the next page. So if you go ahead on your calculator and plug in really small positive and negative h values, you should see that cosine h minus 1 over h is getting really close to 0, and sine h over h is getting really close to 1. So sort of keep those in the back of your head for the next thing we do as well. Next page. Okay, so here is a little bit of review for graphing derivatives. So if we take the sine wave and the cosine wave and we try and estimate what their derivatives look like, we should get, okay, so for example here, let's start with this. These flat spots are all going to be spots where the derivative is 0. So the derivative is 0 at every other tick mark. And then in between, this is over pi over 2, which is about 1.57. And then it looks like it's up kind of close to the same thing, 1.6-ish. So it looks like that thing has a slope of somewhere around 1. And then this looks to be same thing, only negative. And then it's just kind of going back and forth between those. So what you should end up with is something sort of wave looking as well. And then cosine is very similar. Things just happen in different spots. So the derivative is going to be 0 at exactly the opposite tick marks. So every other tick mark starting at negative 2 pi this time. And then derivative is 1-ish here and here. So negative pi over 2 and 3 pi over 2. And then it's negative 1-ish in here. And again, we should see something that's sort of looking like another wave. Okay, so I sort of just jumped right in here and didn't walk through all the directions here based on your work. So let's see, where are we really at? Sketch a graph. Okay, so we're really all the way down to part D. So looking at this, where we started with y equals sine x, we're supposed to look at this graph and say who it looks like. And it looks an awful lot to me like a cosine of x. And then if we do it with this one, where y equals cosine x, I would love to be able to say this looks like sine, but it doesn't quite. Here's sine up here. It looks like upside down sine. So it looks to me like f prime of x is negative sine x. Okay, so there's your preview. Thanks for watching.